You ever wonder how something like ChatGPT just seems to get language? Well, the secret isn't magic. It's actually a revolutionary idea that came out of a 2017 research paper. In this explainer, we are breaking down Attention is All You Need, the paper that basically threw out the old rulebook, gave us the transformer, and yeah, changed AI forever.
So, for decades, AI researchers were wrestling with what seems like a pretty basic problem. How do you teach a machine that language happens in a specific order? The dog chased the cat means something completely different than the cat chased the dog. That order is everything. So how did the old models even try to tackle this?
Well, the old approach seemed pretty obvious, right? Just have the machine process language one word at a time, exactly like we read. But it turns out this common sense idea created a massive bottleneck.
For a long time, the top models for this were called recurrent neural networks, or RNNs. So just imagine the model reading a sentence, word by word. It reads the first word, it creates a little bit of memory about it, then it moves to the second word and updates that memory, and so on down the line. It sounds totally logical, doesn't it? But this step-by-step process had two really big flaws.
Okay, think about a really long paragraph. By the time an RNN got all the way to the last sentence, it might have completely forgotten the crucial context from the very first one. That's what's known as the long-range dependency problem. The other issue? Speed. Because calculating each word depended on the word that came right before it, you couldn't process the whole sentence at once. It was just fundamentally slow. And this table from the paper just makes the difference so clear. Look at the recurrent models on the left. The longer the sentence, that's what N represents, the more steps it takes. The complexity just keeps growing. But now look over at self-attention on the right. It's constant. That means it takes the exact same amount of work to connect the first word to the very last word as it does to connect two words right next to each other. I mean, that is the breakthrough, right there.
So the whole field was kind of stuck. Then, in 2017, a team at Google comes along and asks this totally crazy question. What if this whole one word at a time idea is just wrong? What if we just throw it out completely?
And the title of their paper, it wasn't just some catchy phrase, it was a mission statement. They were claiming you could get way better results by relying only on a mechanism called attention. And you could just get rid of that entire word-by-word structure that literally everyone else was using.
So here's the key idea. Instead of passing a little note down a long line of people, one by one, self-attention is more like being in a room where every single word can look at every other word all at the exact same time. For any given word, the model figures out an attention score to decide how important every other word is to understanding its meaning. This way, it can instantly connect words, no matter how far apart they are.
This idea was so powerful, the authors built an entirely new architecture around it, and they called it the Transformer. Let's take a look inside.
And here it is, the famous diagram from the paper. I know, it looks a little intimidating, but just focus on the two big halves. Over on the left, you've got the encoder. Think of this as the reader. Its only job is to process the input, like an English sentence, and create this rich numerical representation of what it means. Then on the right, you have the decoder, which is the writer. It takes that meaning and generates the output. For example, that same sentence, but in German.
So let's just walk through how it works. First, all the words are turned into numbers, into vectors. But wait a minute, if we're not processing in order, how does the model even know the sequence? That's step 2, positional encoding. This is just a brilliant trick where a unique mathematical signature gets added to each word's vector to tell the model where it is in the sentence. With that context, the input then goes to the encoder and decoder stacks, where all these layers of self-attention do the heavy lifting of understanding and generating language. This slide really shows you the engine of the transformer. See, the model doesn't just analyze the sentence once. It uses something called multi-head attention. The absolute best way to think about this is like having a committee of experts or heads, and they're all reading the same sentence at the same time, but each one is looking for something totally different.
Right, so the original model used 8 of these heads, all working in parallel. One head might be focused on grammar, another one might be tracking who did what to whom, and a third might be looking for more abstract, conceptual links. By combining all these different viewpoints, the transformer can build this incredibly deep and nuanced understanding of the text.
So this all sounds great in theory, right? But did this wild idea of ditching the old way and going all in on attention actually work? Okay, let's look at the results.
The authors put their model to the test on a classic benchmark, translating English to German. And as you can see from this table right here in the paper, the results were just stunning. The Transformer didn't just edge past the previous best models, it set a brand new state-of-the-art record with a score of 28.4.
And that jump of over 2 whole BLE points, which is the standard way you measure translation quality, that was absolutely massive. In a field where progress is usually measured in tiny fractions of a point, this was a monumental leap forward.
And this is maybe even more important, because attention is so easy to run in parallel. The Transformer got these amazing results while training in a fraction of the time. The big model trained in just 3.5 days on 8 GPUs. That efficiency made powerful AI way more accessible and just dramatically sped up the pace of research for everyone.
And get this, it wasn't just a one-trick pony for translation. The authors threw a completely different problem at it, analyzing the grammatical structure of sentences, and it excelled there too, without much special tuning at all. This was the proof. The Transformer wasn't just a translation model, it was a powerful, flexible tool for understanding language itself.
You know, reading the paper's conclusion today feels incredibly prescient. The authors wrote, "We are excited about the future of attention-based models," and they mentioned planning to apply them to images, audio, and video. And well, that's exactly what happened. It led directly to the generative AI revolution that we're all seeing today.
So the real takeaway here isn't just about a new, fancy architecture. It's about the power of challenging an assumption that seemed like total common sense. For decades, everyone just thought AI had to read language sequentially because, that's how we do it. By proving that one simple idea wrong, the Transformer didn't just give us a better model. It gave us an entirely new way to think about intelligence. It really makes you wonder, what other obvious truths are holding us back right now?